So in this video, we will discuss about the probability. Probability is possibility. It is a branch of mathematics which measures the likelihood of occurrence of any random event. So before understanding the probability, we have to know few terms which will be useful for understanding or solving the problems related to probability. First one, experiment. So experiment is a planned operation carried out under controlled conditions. So for example, flipping a coin. So that is an experiment, or flipping one coin twice is an experiment. Now, if you are performing any experiment, you will certainly get an result. So the result is called as outcome. So outcome of an experiment is the result of the experiment. So the sample space S is the collection of all possible outcomes. For example, if you flip a coin once, so either you will get head or tail. So the sample space will be head and tail. If you're flipping two coins, that is a coin twice, combination. So the sample space will be head head, head tail, tail head, and tail tail. Right, so it will have four possible combinations. An event is a collection of one or more of the outcomes of an experiment. Usually the event is denoted by A, B, C, or any other letters. Example, flipping a fair coin twice. So if you flip a fair coin twice, event A can be getting at most one head. So getting at most one head means there will be no head or one head. So no head means TT and then one head means TH or HT. So those are the possible outcomes for event A. Secondly, a second example, it can be even B can be getting two different facings. So two different facing, that means either head tail or tail head. Getting two similar facing. So similar facing means head head, tail tail, right? So there are no other options. Now probability is a numerical measure of the likelihood that a specific event will occur. So I already explained that it is a measure of the likelihood of occurrence of the random event. So probability that event A will occur is denoted by PA and it is given by number of favorable outcome divided by total number of outcomes. So mathematically we can calculate it by this formula, that is number of outcomes favorable to A divided by total number of outcomes for the experiment. Now, if you calculate the probability of A, any probability for any event, it will be always between 0 and 1. So if any probability is 0, so that means it is impossible to happen. That event is impossible to happen and it is called as impossible event. If the probability is equal to 1, so that means 100% chances that that event will happen and it is called sure event. Probability of the sample space is always equal to 1 because the sample space contains all possible outcomes. So the probability of happening of the whole sample space, it will be always equal to 1. So let's see an example how to calculate. So find the probability of obtaining an even number in one roll of die. So when you roll a die, there is equally possible that you get number 1, 2, 3, 4, 5, 6. So all the numbers have equal chances of getting selected. So there are 6 outcomes as we all know. Now our event A is getting an even number. So we have even number as 2, 4 and 6 and the sample space contains the 6 numbers 1, 2, 3, 4, 5, 6 which is the combination of all outcomes. So your probability of A will be 3 because these are 3 in number and divided by total number of outcomes which is 6. So 3 over 6, that is 0.5. That is 50% chances of happening of the event A, which is getting an even number. Another one, 6 of the 250 randomly selected equipments manufactured at a certain auto factory are found to be defective. Assuming that the defective equipments are manufactured randomly, what is the probability that the next one manufactured is defective? So there are 6 defective out of 250 equipments. So 250 is our sample space because we have 250 equipments, and out of each 250 there will be 6 defective. So 6 is the favorable outcome. So your probability that the next equipment is a defective is number of favorable outcome divided by total number of outcomes. So that is 6 divided by 250, which is 2.4%. Very less probability, almost nearer to 0. Right? So 2.4% probability that you get a defective equipment in the auto factory. So next, union, intersection, and complement. The union of two events A and B is a set of all outcomes that are included in either A or B or both. So either A or B or both. This is for both the both. So therefore, it will come under the union. Intersection of the two events A and B is the set of all possible outcomes which is present in both A and B. Present, so it will be included in A union B. So it is denoted by this one, and A intersection B is denoted by this. So A inversed or reversed U sign and then B. The complement of A denoted by A dash. It can also be denoted by all this, that is A complement, A naught, and it is defined as the event consisting of all the possible outcomes which are not present in A, not in A. So whatever is not in A is present in A dash. Right, so probability of A is equal to 1 minus probability of not in A. Right, so you can remember that probability of A is equal to 1 minus probability which is not present in A. So for example, A is red heart cards. So red heart cards, you know, there are 13 red heart cards, right? And total number of cards is 52, and therefore A dash will be remaining. So remaining means 1 minus 13 over 52, which is 39 over 52 will not be red heart cards. So let's see an example here. So roll a fair die. If event B is getting an even number and event A is getting number 1 or 2, then so you need to find all these values. So let's first write A and B. So B is getting an even number and event A is getting number 1 or 2. So B is equal to 246 and then A is equal to getting 1 or 2. So A union B will be either present in A or B or in both. So you will write all the possible combinations like 1, 2, 4, 6 will be your A union B. A intersection B, which is common, which is present in both. So 2 is present in both, so it is your Q. Now what is A dash? So what is A dash? So A dash which is not present in A. So that is 3, 4, 5, 6. And B dash which is not present in B, not in B. So that means all odd numbers. So 1, 3, and 5. Right, so let's see what else it is being asked for. So we calculated A union B, A intersection B, and A dash and B dash. So what else we have to calculate is A dash union B and A dash intersection B dash. So A dash union B and A dash intersection B dash. So to calculate A dash union B, we have A dash here and B here. So either it should be present in B or in A dash or in both. So we can see that 2, 3, 4, 5, 6. So other than that, it is all present. Other than 1, it is every other number is present. So 2, 3, 4, 5, 6. And what about A dash intersection B dash? You can pause the video and try to calculate your own. Always it is a good idea to calculate your own and then see whether your answer is matching with the given answers or not. So A dash intersection B dash, that is which is common in both, which is present in both A dash and B dash. So therefore we can see, so 3 is present and 5 is present. So we can say 3 and 5. Now we calculated all the sets. These are called sets. Now we have to find the probabilities of this set. So we know that total possible outcome was your 6, because if you roll up your die, so you will get 6 numbers, 1, 2, 3, 4, 5, 6. And you have how many you can get for these events. So you can calculate that easily. So the first one, probability of A union B. So 4 divided by 6 is the total number of outcomes. So 4 divided by 6. Probability of A intersection B is 2. 2 is, that is only one possibility is there. So 1 divided by total 6 possibility. A dash, probability of A dash, that is 4 divided by 6. Probability of B dash, that is 3 divided by 6. Right now, we have calculated probability of, A dash union B as 2, 3, 4, 5. So therefore, probability of A dash union B, so we can write, so this is your probability, we can write it here. So probability of A dash union B will be 4, because these are 4 in numbers. So 4 divided by 6, because in total there are 6 possibilities. And for this one, probability of A dash intersection B dash, it is your number of favorable outcome, which is 2, and all possible outcomes, it is 6. So 2 over 6 is the probability of A dash intersection B dash. You can write the final answer into the smallest equivalent fraction. All right, always your answer should be in smallest form. So for example, for 4 over 6, it is 2 over 3. So 2 over 3 is the correct answer for probability of A union B. Conditional probability. The probability of an event A given that an event B has occurred is called conditional probability of A given B, and it is denoted by PA over B, and it is read as probability of A given that B has already occurred. So here there are two events A and B, and if you have to find the conditional probability where B event is already occurred and you are finding the probability of A if you know already that B has happened. So then you will use the conditional probability. So here the formula for that is, if there are the A and B are two events with probabilities not equal to 0, then probability of A given B is equal to probability of A intersection B over PB, and B given A is equal to probability of A intersection B over PA. Now, one way to remember this is whatever is the given event, so that will be there in the denominator. So A over B, you know, the A intersection B in the numerator, which is in both the formulas. Now B, because here B is given, so therefore it is P probability of A intersection B over probability of B. And because here A is given, so it is equal to probability of A intersection B divided by probability of A. Right now, using this formula, we will solve a small example. So, rolling a fair die. So, I have rolled a die once. What is the chance that I got 3? So, you know that rolling a dice, what will be the possible outcomes? Can you pause the video and tell me what can be the possible outcome? So if you roll a die, the possible outcomes or sample space is your 6. That means you can get 1, 2, 3, 4, 5, 6. So your sample space will be equal to 1, 2, 3, 4, 5, 6. Right? Now, A is an event of getting 3. So we can get only one time 3. So A is the event of getting 3. So therefore, probability of A is number of favorable outcomes, which is only 1, and divided by total number of outcomes, which is 6. So 1 over 6. So we got probability of A is equal to 6. That is probability of getting 3 when a die is rolled. Now consider that I tell you the number I got is odd. So you already know that the number whatever you will get is odd. What is the chance of getting 3 now? So there is another event. So event B. So event B is getting an odd number. So event B is getting an odd number, and there are 3 odd numbers, 1, 3, 5. And the probability of B will be equal to 3 over 6, because 3 is the possible favorable outcomes and 6 is the all possible outcomes. So probability of B is equal to 3 over 6, that is half. Right? And then you have to find what is the chance of getting 3 if you already know that the numbers are odd. If you already know that your B has already occurred, or you already got that number as odd, what is the chance that that number is 3? So you will use the formula as probability of A intersection B divided by probability of B. Now A intersection B you can calculate. So what is A intersection B from here? So from A intersection B, you can calculate it as there is only one number in common, which is 3. So therefore, probability of A intersection B is 1 divided by 6, right? Because there is one possible outcome and divided by 6 outcomes in total. So this is your 1 over 6, and probability of B is your half. Right, so you can calculate what will be the value here. So 1 by 6 and 1 divided by 1 by 2, so which is equal to 1 by 3. So therefore the probability of A given B is 1 over 3.